Hi, everyone. This is Joe McIntyre, one of the instructors for the evidence course. Today, we're going to be talking about causal effects, what it means to look for a causal effect and how we detect them. And we're going to be doing this in the context of one of the articles that the pre-K strand has been asked to read this week. So what is a causal effect? When we are asking questions about causal effects, what we want to know is, do changes in some variable, x, cause changes in y, some other variable? Some very common questions that we'll ask, especially in the world of education, is something like, did exposure to a treatment, some sort of an intervention, impact some outcome of interest? Another very common question in education is something like, did a policy change affect the sorts of things that it was supposed to? A key idea behind these questions is that they're not asking whether two things are associated with each other. They're asking whether one thing actually had an impact on another or caused another thing to change. The example we're using for this particular presentation, it's from an article, The Impact of Jalan Sesama. This is Indonesian for sesame seeds, on the educational and healthy development of Indonesian preschool children. So specifically, in general, what these authors are interested in finding is, does being assigned to watch sesame seeds have an impact on children's outcomes? And specifically, does it have an impact on their cognitive outcomes and on their safety? We're going to be focusing on the cognitive outcomes in this particular presentation. But keep in mind, that's the question. It's not a question of whether kids who watch this particular program, Sesame Seeds is a preschool age children's television programming. The question is not just, do children who watch this differ from children who don't? The question is, does watching this program actually affect children's outcomes? So here would be one approach that we might immediately think to take, and it would not be a good approach, but it's very easy to land on this on a first pass. So the first thing that we might think of doing is, well, let's just go out in Indonesia and find a group of children who have watched Jalan Sesama, maybe people who watch a lot of it, and another group of children who don't, measure these children on the cognitive outcomes that we're interested in, and compare them and see if there's a difference. It might seem very straightforward. It's using the tools of descriptive statistics that we've talked about before. We're looking for an association, but in the end, it's not going to answer our question. So we want to start by asking ourselves, what is wrong with this approach? A problem with this approach is something called confounding. The problem is that if we find differences between these two groups of children, the differences that we observe may not be due to the program. It may be due to something other than Jalan Sesama. So specifically, we might wonder if children who watch Jalan Sesama could also be wealthier, for example. They come from households that own televisions. They come from households that have access to electricity. They may be members of a privileged group. Indonesia has a lot of different languages. These are children who are able to watch programming in the dominant language of Indonesia, and that could be a sign of privilege on the part of these children. They could be different in other ways that we're just not thinking of. And the problem is that if we do see a difference between these two groups, we won't know if we can attribute it to watching Jalan Sesama, or if they could have been different in other ways to begin with. The differences may not be due to the programming itself. So this approach, as tempting as it may be, would ultimately not be successful. We do have a solution to this, though. And this is where we talk about experimental evidence. The approach adopted by the authors in this article was to take a group of children and randomly assign them to different groups. Randomly assign the children to watch Jalan Sesama or not. And what this will guarantee is that because these children have been randomly assigned to these different groups, there will be no systematic differences between the two groups in terms of other variables. The only systematic difference between the two groups is that some of them have been assigned to watch this program at their schools, and the others have not. So if we see differences between the groups in the end, those groups have to be due to the treatment. A little bit more precisely, what the researchers did was they created 3 groups. There was one group who were not assigned to watch Jalan Sesama. They may have done it on their own, but they were not given access to the intervention materials. Another group was assigned to watch a little bit of Jalan Sesama, In their schools, they were asked to watch 1 episode per week for 14 weeks. And then the last group was given high exposure to Jalan Sesama, 3 episodes per week for 14 weeks for a total of 52 episodes. After this random assignment, after the 14 weeks had elapsed, researchers measured the 3 groups, and this is what they found. This is a table of regressions. Regressions are one tool that we use to study causal impacts. If you take some of the more advanced classes in methods at the School of Education, you'll learn more about this technique. What we want to focus on are the rows which are entitled exposure group. And the first row is exposure group low compared to control. And what this is doing is it's comparing the outcomes for children who received low exposure to Jalan Sesama to those who received none whatsoever. And this is comparing children who are of the same age, the same gender, have the same baseline score on each of these different measures, and have parents with the same level of adult education. So if we look at the entries in that row, each one is comparing these low exposure group children to the control children in terms of their early cognitive skills. These are effect sizes, which we've discussed before. It's a standardized measure of how large the difference is. Remember, we've seen before these stars that are next to the numbers indicate statistical significance. And if we read across the low exposure group, we'll see that for none of the outcomes of interest do we see evidence that Jalan Sesama impacted their cognitive skills. So for every different cognitive skill, we see that the low exposure children were slightly better off than the control children, but we can't say that this is a reliable effect. We don't have evidence that this is due to more than just chance. In contrast, if we look at the second row, this is now comparing the high exposure group to the control group. And what we see is that for early cognitive skills overall, and specifically for number recognition and counting, we have evidence that children holding constant baseline score, gender, age, and adult education, children who had high exposure to Jalan Sesama tend to be better on all of these measures at the end of the intervention than children who were not assigned to that group. And from that, we can say that Jalan Sesama actually impacted these children's early cognitive skills, number recognition, and counting ability. It's not just that these children are different, it's that this difference was caused by the program. In contrast, when we look at some other outcomes, letter recognition, early reading and writing, and arithmetic, we can't say that. It doesn't mean that the program didn't have an effect on those other ones. It means that the evidence is not strong enough to convince us that this is due to anything other than chance. Great, so thank you so much. This was the presentation about causal effects. We'll be talking about this more in the context of this article and in the articles assigned to the other groups in the coming week.